let's explore the concept of solution equilibrium, okay? So imagine you have a cup of water out here, for example, and you have a solute in here. Let's say it's sugar, okay? So you have water out here, and that's a crystal of sugar, okay? And once you add the sugar into this water, what's going to happen is the sugar is going to start to dissolve, and that's the little blue arrows, which means these little molecules, the little circles are molecules. Those little molecules are trying to go into solution, okay, to mix with the water. And between sugar and water, those are your dipole-dipole interactions, okay? So they're going to try to go into water because of those intermolecular forces that are at play, okay? So after some time, this is what's going to happen. So what you see out here is some of those crystal molecules of sugar have actually broken off from the crystal and have dissolved in the water surrounding them, okay? And by the blue arrows, you can see that it's still dissolving, which means more and more molecules are going. But at the same time, some of those molecules are going to try to come back and re-establish their force with the crystal. And the reason for that is because these molecules also have an intermolecular attractive force between themselves. Now, so there's two forces out here. There is the solute-solute attractive force, and then there is the solute-solvent attractive force, okay? And there's essentially a tug-of-war between the solute-solvent, the forces between them, and the solute-solute. Right now, the solute-solvent is winning, okay? So as you can see, there's a lot more solute going into the solvent than solute coming back to solute, okay? So as a result of this, this solution is unsaturated, which means you can still dissolve more solute in it, okay? So we're going to label this unsaturated. Now, this is going to continue going, and after some time, this is what's going to happen. So now you have a saturated solution where you can see that a lot more crystals, a lot more molecules have gone into solution, and the number of blue arrows equals the number of red arrows, which simply means that the rate of dissolution, so the blue arrows is the rate of dissolution, so the number of molecules going into solution, equals the red arrows coming down, where these are trying to reform the crystal, okay? So these two molecules are trying to reconnect with the crystal. So that is the rate of recrystallization, okay? So at this point in time, this solution is saturated. And when saturation takes place, then your rate of dissolution is equal to the rate of recrystallization. Now, it turns out if you don't change the temperature, everything's going to stop out here. And this is the case of dynamic equilibrium. Why dynamic? Because there is still molecules trying to go into solution, and at the same time molecules from solution are trying to crystallize out, okay? So it's dynamic, it's a back and forth, okay? It doesn't look like there's any change, but the reality is that there is a back and forth going on, and the rate of the dissolution is equal to the rate of the recrystallization, okay? So that is the case of saturation, and that is your solution equilibrium. So at this point in time, everything is at equilibrium, okay? Now, if we change the temperature, so if we heat it up, so if we add some heat to this, what's going to happen is it's going to provide more kinetic energy to those molecules, which means these crystals are going to break apart, and more of these are going to go into solution. So very likely all of that is going to go into solution, okay, because the water molecules are going to get more energy as well, and they're going to kind of vibrate around more to create more space for those solute molecules to come in. As a result of that, what's going to happen is all of this is going to go into solution, and then you're going to have another case of unsaturation at a higher temperature, okay? Now at that point in time, if you recool things down, so if you drop the temperature slowly, what's going to happen is you're going to initiate recrystallization.